In the semiconductor electronics, we are having an important concept, that is a transistor. What do you mean by transistor? So transistor is a three-terminal, two-junction semiconductor device. Okay. So the transistor consists of a three-terminal and a two-junction. So we have an actual representation of transistor. It is like that. So I can write a block diagram here. Three-terminal in the sense that the first one is emitter, and another one we can call it as a base, and the last one we can call it as a collector. So the emitter is one terminal, a base is another terminal, and a collector is the third terminal. Three-terminal. So two junction. Here junction is formed in between. These emitter base terminal. This is one junction. This is the first junction. And so another junction is formed between collector and base. Okay. First and second. Okay. Two junction. Emitter base collector. These are the three terminals of the transistor. Okay. And the junction is formed between emitter base terminal and the collector base terminal. Fine. So what is the actual function of this transistor? So the transistor, we can call it as a transfer resistor. We can call it as a transfer resistor. What do you mean by that? Why we can call it as a transfer resistor? So this transistor transfers electric current I. We can represent by the symbol I. So transfer electric current from a region of low resistance, to high resistance region. Okay. So here this transistor transfers the electric current from the low resistance to the high resistance region. So first we have to know what about the low resistance region and what about the high resistance region. By following emitter, base and collector, we come to know that what about the transfer resistor and what about the how we can transfer the electric current from a region of low resistance to the high resistance region. First we go one by one about emitter, about the base and about the collector. Let me see that. And you can pause and note the definition. Emitter. So emitter terminal, it is highly doped region. This one is a highly doped region. We can add a trivalent or pentavalent impurities with respect to the N and P type material. So for N type material we are adding pentavalent impurities. To prepare P type material we are adding trivalent impedance. Okay. So here emitter it is a highly doped region. Okay, highly doped region. So what is the function? What is the actual function of emitter? It injects majority charge carriers. It injects majority charge carriers towards base region. So this is the very important point. We have to concentrate. Emitter, it injects a majority charge carriers. Majority carriers, or we can write this majority charge carriers. Majority charge carriers towards the base region. Okay, fine. Next, another one is, that is the middle one, base. What do you mean by the base? Base terminal. So here base terminal is least doped. We can call it as a least doped region. We can call it a least doped region. Okay. So what about the function of this base? What about the function of this base? Base transfers majority charge carriers. Majority charge carriers towards collector region. This is the function of base. This one is the least doped region, and it can transfer a majority charge carriers which are coming from the emitter. Emitter is injects all the majority charge carriers to the base region. Okay, and what we got from the emitter, that is transferred to the collector region. Okay, here emitter, base, collector, we are having the block diagram: emitter, a base, and collector. Okay, so here emitter injects the majority charge carriers, either E minus or E plus. Okay, so base transfer the majority charge carriers towards the collectors. Okay, fine. Then what about the collector? What about the collector? So it is, we can call it as a moderately doped. It is a moderately doped region. Collector is a moderately doped region. It can collects all majority charge carriers. All majority charge carriers. It collects all majority charge carriers. Okay. If we go through the size of the emitter, base, and the collector, base is having a very small thickness. Base is having a very small thickness, so it is a lightly doped. It is a least doped region. Okay, here compared to the collector and the emitter, as I have mentioned, the size of the collector is greater than size of the emitter. Okay, size of the collector is greater than size of the emitter. That means thickness of collector region is greater than thickness of emitter region. Compared to emitter and collector, base region is having a very small thickness, and it is leastly doped region. This one is a leastly doped region.